In question 2a, we must prove that sine a plus b is equal to sine a cos b plus cos a sine b. In our proof, there's three results that we're going to need to use. Firstly, cos of 90 minus theta is equal to sine of theta. Second, sine of 90 minus theta is equal to cos of theta. And third, cos of x minus y is equal to cos of x times cos of y plus sine of x times sine of y. The starting point of our proof is to take statement 3 and let x equal to 90 minus a and let y equal to b. Now, I'll rephrase things a bit on the left-hand side. Minus a minus b can be rewritten as minus a plus b all in brackets. From here, we can use results 1 and 2 several times. Letting theta be equal to a plus b in statement 1, we see that cosine of 90 minus a plus b is equal to sine of a plus b. Letting theta be equal to a in statement 1, we see that cosine of 90 minus a is equal to sine of a. Letting theta be equal to a in statement 2, we get sine of 90 minus a being equal to cosine of a. Putting everything together, we've ended up with the sine of a plus b equal to sine of a times cos of b plus cos of a times sine of b. This is the exact statement we needed to obtain. In part B, we must use the formula from A and without using a calculator, find the value of sine 75 degrees. Well, since we can't use our calculator, we'll have to rely on the formula book. If you turn to the appropriate page, you'll find the sine, cos and tan values for 0, 90, 180, 270, 30, 45 and 60 degrees. The target angle, 75 degrees, can be written as a sum of two of these. 75 is equal to 30 plus 45. Hence, we can rewrite the sine of 75 as sine of 30 plus 45. The formula in part A said that sine of a plus b is equal to sine a cos b plus cos a sine b. Applying this statement with a equal to 30 and b equal to 45, we end up with sine 30 times cos of 45 plus cos of 30 times sine of 45. The values of each of these are given to us in the formula book. Sine of 30 is equal to a half. Cosine of 45 is 1 over root 2. Cosine of 30 is root 3 over 2. And sine of 45 is 1 over root 2. To multiply fractions, you multiply together the numerators and multiply together the denominators. We can use this to simplify. For 1 over 2 times 1 over root 2, the numerator will be 1 times 1, which is 1. The denominator will be 2 times root 2, which is 2 root 2. Now for the root 3 over 2 times 1 over root 2. The numerator will be root 3 times 1, which is root 3. The denominator will be 2 times root 2, which is 2 root 2. You'll notice that both our fractions have the same denominator. To add fractions with the same denominator, all you have to do is add the numerators. So the final answer here comes out as 1 plus root 3 all over 2 root 2. In part C, we must find all the solutions of the equation sine of t is equal to sine of 2t. Here, t is an angle between 0 degrees and 360 degrees. To start, I'm going to group everything together on one side of the equation. To remove the plus sine 2t on the right, we can subtract sine of 2t from both sides. Next, I'll turn to a result in the formula book which says that sine of 2a is equal to 2 sine of a cos of a. Applying this with t in the slot of the a tells us that sine of 2t is equal to 2 sine of t cos of t. Now we have a common factor of sine t on the left-hand side. This can be factored out. When we take out sine t from sine t, we're left with 1. When we take out sine t from minus 2 sine t cos t, we're left with minus 2 cos t. We've reached a situation where we have two quantities, sine t and 1 minus 2 cos of t, being multiplied together to give 0. The only way that this can happen is if one of the quantities itself is 0. So either sine t is equal to 0, or 1 minus 2 cos of t is equal to 0. We'll need to find the solutions for each of these equations. Focusing on the first of these, I'll begin by taking sine inverse of both sides. Using our calculator, sine inverse of 0 is 0. This tells us that the reference angle is t is equal to 0. Unfortunately, this isn't the only solution here. There's going to be a second solution contained within the first rotation of a circle. To find it, we can use our rules for the unit circle. If you have an equation involving sine, you should subtract the reference angle from 180. Here, the reference angle is 0, so the second solution will be 180 minus 0, which is 180. Another important thing to note here is that the interval we're given for t, 0 is less than or equal to t, is less than or equal to 360, contains both the endpoints, 0 and 360. Given any solution to a trigonometric equation, if we add a full circle of 360 degrees, you'll get another solution. We found that t equal to 0 degrees is a solution, so 0 plus 360, which is 360, is also a solution. This will have to be included because 360 degrees is contained within the given interval. Now let's turn our attention to the second equation. 1 minus 2 cos of t is equal to 0. To begin, I'll remove the minus 2 cos of t from the left by adding 2 cos t to both sides. Next, I'll remove the multiplication by 2 by dividing both sides by 2. Then, I'll get rid of the cos by taking cos inverse of both sides. We can use our calculator to find cos inverse of 1 over 2. This will come out as 60 degrees, So the reference angle here is t is equal to 60. Again, we'll have to use our unit circle knowledge to find a second angle. Whenever you have an equation involving cos, the second angle is obtained by subtracting the reference angle from 360. Here, the reference angle is 60, so we get 360 minus 60, which is 300. Putting everything together, we ended up with 5 solutions. T equals 0 degrees, 60 degrees, 180 degrees, 300 degrees, and 360 degrees.